Electricity is as much a part of today's lab as you and I. Without it, operations would come to a standstill. Our fancy equipment would be gathering dust, and I'd be cranking this centrifuge by hand.
Electricity is literally everywhere in our labs. Because it is, we need to know how to work with it safely. Accidents and equipment problems can cause electric shock or ignite flammable vapors. Performing equipment maintenance or making adjustments without taking proper precautions can result in serious injuries. And sparks from malfunctioning equipment can even cause explosions.
We need to know electricity inside and out. That's the only way to be safe. Let's begin by reviewing a few fundamentals.
The force carried by the electrical current is measured in volts. Most equipment runs on about 120 volts. Equipment requiring large amounts of electricity often runs on specially dedicated 240 volt lines. Current is the flow of electricity. The intensity of the current is measured in amperes or amps. The amount of current that an electrical line can safely hold can vary, depending on the thickness of the wire. In general, most lines in the lab can safely carry 20 amps. You may have heard this before, but it's worth repeating. It's the flow of current, or amperage, not the voltage, which causes shocks. And it doesn't take much to cause serious injuries. In fact, exposure to 0.06 amps, the amount of electricity needed to power this Christmas tree bulb, can be fatal if it passes through a person's heart. We need to exercise caution at all times.
Electricity flows when a loop or circuit is completed. Now, a loop is the uninterrupted passage of electricity from the power source through the instrument and back again.
To regulate this loop, machines and equipment have an on and off switch. When the switch is on, the loop is complete and electricity will flow. Moving the switch to the off position breaks the flow of electricity and prevents the equipment from running. As a safeguard, the flow of electricity can also be broken by a fuse or circuit breaker located within the instrument or externally in the lab. If the wires carry more electricity than they can safely handle, they become overloaded. When this occurs, the fuse or circuit breaker will trip, disrupting the flow of electricity. Another important principle to remember is that stray electricity is always being pulled toward the ground. This can lead to a nasty shock if you're in its path. Controlled grounding is what provides us with a safeguard against this stray electricity. If electricity leaks through insulated wiring and there's stray electricity running around, then the ground wire will direct the electricity back to ground, not to the person touching the failed equipment. You can see the ground wire easily in 3-prong plugs. In order for a ground wire to be effective, the outlet that it's plugged into must be connected to ground. Outlets should be tested annually to make sure that they are still grounded. It's important to remember that a 2-prong plug is never grounded. As a result, equipment without 3-prong plugs must be grounded with a separate wire. For added safety, outlets can be fitted with a ground fault interrupter, or GFI. This device will protect you from leakage of current in equipment. The GFI senses stray electricity by measuring the continuity of the current. If any deviation exists, the device will shut off the flow of electricity before it can cause any problems. Ground fault interrupters act quickly. They protect you by cutting off the flow of electricity right at the outlet. This can be a real lifesaver because circuit breakers alone can't halt dangerous amounts of electricity fast enough to protect you from an electric shock.
Following safe work practices is also critical to working safely around electricity.
To begin with, we need to remember that electricity can be dangerous. The 3 most common electrical hazards are fires, shocks, and burns. Be on the lookout for the causes of these hazards. A number of problems involve faulty wiring. Before plugging in a piece of equipment, Check the insulation on all wiring for cracks and other defects. Report any problems and have faulty wires immediately replaced or serviced. Don't overload circuits. This will cause the wiring to heat up and increase the risk of an accidental fire. Limit the use of extension cords. Eventually, they'll develop cracks and other defects that lead to shocks, and these problems can't be covered up with electrical tape. So play it safe and move your equipment within easy reach of an outlet. Be sure that all electrical equipment is properly grounded while you're working. If you're using a two-pronged outlet with an adapter, don't forget to connect the ground wire. Never alter three-pronged plugs to fit into two-pronged outlets. This prevents stray electricity from heading to ground and leaves you vulnerable to an accident. Play it safe. Always use caution when selecting electrical equipment. Whenever possible, use double insulated tools. They have built-in protection against shock. With these tools, a special safety shielding conducts stray electricity away from you to the ground wire. Sometimes equipment may appear to be working properly, but upon closer inspection, there may be a problem. For instance, a machine with damaged connections can spark. Be careful. Electrical sparks can ignite flammable liquids, vapors, and dusts. Make sure that repairs are made as soon as possible. Tell your supervisor about any problems and contact a qualified repair person. Don't try to do it yourself. If you need to get inside an instrument to make an adjustment or perform routine maintenance, disconnect all power sources before opening it. Practice proper lockout-tagout techniques. Consult your supervisor if you have any questions. In areas where flammable materials exist, it is especially important that you choose the equipment you work with carefully. Motor-driven electrical equipment should be equipped with non-sparking motors and switches that limit the possibility of an accidental fire. This includes items such as vacuum pumps, mechanical shakers, and stirring devices. Never bring home appliances into a lab where flammables are present. Most of these have switches that may spark. Maintenance crews often bring power tools and vacuum cleaners into our labs. Their motors can create sparks as well. Before this equipment is used, make sure that the lab is free of flammable vapors. Prevent water and other liquids from contacting or flowing onto electrical equipment. Water can damage sensitive electrical circuits and may leave you vulnerable to a shock. Guard against any contact with energized parts. Do everything you can to prevent exposure and limit accidents.
If despite your best efforts something goes wrong, it's important to be prepared.
Never touch a person who is in contact with a live wire. Cut off the electrical current at an emergency off switch and immediately call for emergency medical personnel. Because of the heat generated by electricity, accidents often result in fires, so fire safety is also very important. Know the location of fire extinguishers near your work area. Electrical fires demand the use of Type C fire extinguishers. But if a fire is too much to handle, get out. Leave it to the professionals. A working knowledge of first aid can also be very helpful. Cover minor electrical burns with loose, dry, sterile dressings and bandages. Make sure to get medical attention in case there are any complications. And since electrical accidents are often serious, victims may need CPR or treatment for shock. Learn how to administer CPR. Ask your supervisor about first aid training.
Electricity is a valuable asset. We should use it correctly and safely. Follow proper work practices. Report any unsafe conditions. Remember not to attempt repairs unless you're qualified to make them. And be prepared in case of an emergency. Electricity makes our labs more efficient, and it's up to us to make sure that we take all the necessary precautions to work with it safely.